So we have this information that the first term of a series is 1/2, and the rule of the series is to multiply the term by 2 and then divide it by the term plus 2. So our first question is to find the equation for an. So what does an equal? And our second step is to prove that prove our answer is correct. Our first step is to see what happens. So let's just test it out. When we have the second term, a2, that's the same thing as 2 times a1, which is, we already know it's 1/2, over the first term plus 2. This is the same thing as 1 over 5 over 2. Same thing as 2 over 5. When we have the third term, it's 2 times the second term, which is 2/5, over the second term plus 2, which is 4/5 over 12 over 5. And this is the same thing as 1/3. So then, can we see a pattern over here? Well, if we rewrite this first term, it's the same thing as 2 over 4. This second term is already 2 over 5. And this third term can be rewritten as 2 over 6. So we see a pattern over here. A1 is 2 over 4. A2 is 2 over 5. A3 is 2 over 6. And so on. So then this is probably true. So for an, the equation is probably just 2 over the nth term plus 3. But then we have to prove that our answer is correct. So this is where we start to use the mathematical induction method. We have to assume that when n is equal to k, the kth term is equal to 2 over k plus 3. This was the equation we came up with. And we're going to assume that this is true and then build off of our assumption. So then when n is equal to k plus 1, what will happen? Well, when n is equal to k plus 1, we can use the equation they gave us over here. So the k plus 1 term must be equal to 2 times the kth term over the kth term plus 2. And in the beginning, we assumed that ak is equal to 2 over k plus 3. So then we can replace these ak's with 2 over k plus 3. This means we are left with 2 times 2 over k plus 3 over 2 over k plus 3 plus 2. We can go ahead and simplify. 4 over k plus 3 divided by 1 over 2 times k plus 3 plus 2 over k plus 3. And this is the same thing as 4 over k plus 3 times k plus 3 over 2k plus 8. So then this top and bottom cancel each other out, and we can divide a 2 from the top and bottom. So we're left with 2 over k plus 4. And if we rewrite this, it's the same thing as 2 over k plus 1 plus 3. So then, when n is equal to k plus 1, it still falls under the same pattern. It's 2 over n. In this case, it was k plus 1 plus 3. These two are essentially in the same format, which means that we have proven our answer is correct. So the equation for an is just 2 over n plus 3.